Welcome back, everyone. In this video, we are looking at the sum and difference identities for our trig functions. So the first ones we're looking at here are the sum and difference identities for sine and for cosine. So cosine of one angle minus another, or cosine of one angle plus another. Now, the reason why we're looking at them is they will help us with problems like this, finding cosine of pi over 12, or in other words, cosine of 15 degrees. And if you're thinking about 15 degrees, that would be the same thing as 60 degrees minus 45, which, using the formula on the previous page, that would be cos of pi over 3 times cos of pi over 4, plus sine of pi over 3 times sine of pi over 4. And at that point, we are just using our special triangles to evaluate these. And simplifying, and then we are finished. So there we go, just a nice little application of this formula. So cos of 15 degrees is the same thing as cos of 60 minus 45. Apply the formula, use the special triangles, and away you go. Same thing for this one, cos of 7 pi over 12, that's 105 degrees. If you're looking at cosine of 7 pi over 12, 105 degrees, that is cosine of 60 degrees plus 45. And then again, just applying our formula. And then evaluating using our special triangles. There we go. There we go. Now we have the exact value of cosine of 7 pi over 12. One thing that we can do is to use one identity to generate the other. If you know the difference identity, with a little bit of clever work, you can generate the sum identity for yourself. And that's what we're going to do in the next example. Starting with knowing the difference identity, how can you derive the sum identity for cosine? So if you only knew cos of alpha minus beta and you wanted the formula for cosine of alpha plus beta, you could just use the fact that cosine of alpha plus beta is the same thing as cosine of alpha minus negative beta. And at that point, you've rephrased it as something where it's a difference of two angles, so you can use the angle difference formula. Cosine alpha, cosine negative beta, plus sine alpha, sine negative beta, and then using the fact that cosine is an even function and that sine is an odd function. And then there you go. You've generated for yourself the identity for the cosine of two angles that are added. Cos of alpha, cos of beta, minus sine of alpha, sine of beta. Let's do another. Here, and this time we're now going to talk about how to generate the two formulas that we have for the sine function. Here we've got the difference identity and the sine identity for the sine function. And the key here is that we can start again using the cosine identities that we know, because the complementary angle theorem from back in chapter 7 tells us how we can relate values of the cosine function with values of the sine function. Cos of one angle and sine of 90 minus that angle are both equal. Same thing with sine of an angle and cos of 90 minus the same angle. Those are equal. Complementary angle theorem told us that cofunctions of complementary angles, sine and cosine, those are cofunctions. Complementary angles, those are angles that differ by 90 degrees, that those would be equal to each other. So that's sort of the idea here, is that if you're looking to derive the identity for sine of alpha plus beta, you can actually rephrase it in terms of cosine, because sine of this angle, alpha plus beta, is the same thing as cosine of 90 minus that angle of alpha plus beta. I'm just going to rewrite this a little bit here. Cosine of 90 minus, in brackets, alpha plus beta is the same thing as cos of pi over 2 minus alpha minus beta. which if I wanted to rewrite that so that it would look like a difference of angles, I could rewrite that as cos of pi over 2 minus alpha minus beta. So here, the two angles that I have, the one angle is 90 minus alpha, the other angle is beta. And then now we just use the formula that we have already established, the one for the difference of two angles for cosine. That would be cosine of the first angle, cosine of the second, plus sine of the first angle, sine of the second. And at this point now we're just going to reapply the complementary angle theorem. Cos of 90 minus an angle could be turned into sine of that angle. Sine of 90 minus an angle could be turned into cosine of that angle. So cos of 90 minus alpha, that's sine of alpha. Sine of 90 minus alpha, that is cos of alpha. And there we go. We've generated the sum identity for the sine function. If we wanted to now generate the difference identity for the sine function, it's not too hard to do, because if you're looking for sine of alpha minus beta, we already have established the identity for sine of alpha plus beta. So I'm going to rewrite this as the sum of two angles, sine of alpha plus negative beta. And then I can apply the formula that we've just identified or just established on the previous page. Sine of the first angle cosine of the second, plus cosine of the first angle sine of the second. And then now just using the fact that cosine is even and that sine is odd, and now we've established our identity for sine of alpha minus beta. We have two more identities. These are the identities for the tangent function, the sum and the difference. So the difference identity and the sum identity. And to derive them, I'm only going to derive one of these, the difference identity. The sum identity is pretty much the same as far as the steps you would go. The key idea here, of course, if you wanted to generate the formula for tangent of alpha minus beta, you can use the fact that tangent is sine over cosine. And so that's what I'll do here. I'm basically going to now reuse the formulas that we have from the previous slides for sine and for cosine. So sine of alpha minus beta, that's sine of alpha cosine of beta minus cos of alpha sine of beta. And cosine of alpha minus beta, that's cosine alpha cosine beta plus sine of alpha sine of beta. So just to recap what we did here, we started with, we want the identity for tangent of alpha minus beta. We've rewritten tangent as sine over cosine. And now the idea here, of course, is notice that the formula is all in terms of tangents, and we know how we could make tangents happen. Tangents are sine divided by cosine. So my plan here is to get rid of all the cosines. I'm going to divide everybody, top and bottom, by cosine alpha, cosine beta. So that's why I've left a little bit of room here. So we're dividing everybody by cosine alpha, cosine beta. And a lot of things cancel out, and other things will turn into tangent functions. So simplifying a little bit, we can see that some things are canceling. We have cosine beta and cosine beta cancel. We have cosine alpha and cosine alpha cancel. Here we've got cosine alpha and cosine alpha canceling, and also cosine beta and cosine beta canceling. And the things that are left are all tangents. Sine alpha over cos alpha, that's tangent of alpha. Sine beta over cos beta, that is tangent of beta. We've canceled out here. That's canceled and that's canceled. So what should be left is just 1. And this is tangent alpha. This is tangent beta. So we have tangent alpha, tangent of beta. All right. Okay, good work, everyone. I think here's a nice spot for us to take a pause, and then when we come back, we'll do some more applications involving these identities.